Hey, this is Rob with Codecademy. For our SQL project, we're going to take on usage funnels with Warby Parker. To be successful in this project, you'll need to be familiar with using joins to combine columns and records, building a usage funnel, calculating, and summarizing the data that results. Alright, let's get started. Alright, our project begins with some information about Warby Parker and their work. How for every pair of eyeglasses and sunglasses sold, a pair is distributed to someone in need. So in this project, we're going to analyze different Warby Parker marketing funnels in order to calculate conversion rates. So here are the funnels and tables that we've been given. A quiz funnel with survey, and a home try-on funnel with quiz, home try-on, and purchase. This project was done in collaboration with Warby Parker data science team, so thanks to them for that, and it uses fictional data. So let's go ahead and get started with our first task. So the first step is going to be to select all of the columns from our table called survey. And we want to restrict this just to the first 10 records or the first 10 rows. And we want to be sure to end this with a semicolon. Now we can go ahead and click save, and we can take a look at what columns the table produces. There's the question column, the user ID column, and the response column. The question has the text for what the survey question is, the user ID has the user-specific ID, and the response has the response the user has given. So for instance, in our first row, the user is asked the question, "What are you looking for?" And they responded, "Women's style." In our second row, we have the same user, we can tell from the matching user ID, that was asked, "What is your fit?" And they responded, "Medium." So let's mark step 1 as complete and go ahead and move on to step 2. Now, while you're in school, when you're given a quiz, you want to answer all the questions that you can in hopes of getting all the possible points that you can. However, when quizzes are given out to the public, people will give up at different points in the survey. So our next task is to find out how far people get in this survey before they quit. So we're going to analyze how many users move from question 1 to question 2 to question 3, etc. And we'll create this quiz funnel using the group by command. So let's select the column question, and we want to get a count of how many people answer each question. So we can use count that we've learned earlier, and what we'll pass into count is distinct user ID. And so those are going to be our two columns that will provide a column for the question and a column for this total count. And we're going to get this from our table survey. And lastly, we want to group by question. Let's go ahead and make our query. And we can see that the first question has 500 distinct users. The second question has 475 users. The third question, 380 users. And down the numbers go. So we can see that after the first question of 500 users, the second question only has 475, which means that 25 people dropped off. Then at our next question, we find that a total of 95 people drop off, a much steeper decline. But then for the fourth question, for those who have stuck it out through the first 3, we notice only a drop off of 19. And so we can take a look at the results of that fifth question. I'll go ahead and comment out our first query. And we can see for the last question, there's actually a very steep drop-off. So this would cause you to ask, if there wasn't much of a drop-off from question 3 to question 4, why was there such a drop-off from question 4 to question 5? It might relate to some difficulty in understanding or giving an answer to that specific question that was asked. So let's go ahead and mark step 2 as complete and move on to step 3. This is where you would use a spreadsheet program like Excel or Google Sheets to calculate the percentage of users who answer each question. We can already see that 270 people answered the last question, which means that roughly about half the people who started the quiz actually answered the last question. So I went ahead and used Google Sheets, and I created a little formula that looked at the value in column B, and then divided it by 500 for each row. And the result, as we saw, was 100% of the first question, followed by 95, 76, 72, then 54. So that might suggest that in the general population, once someone takes a couple questions in a survey, they may not have the attention span to continue. And we also saw that with a significant drop-off from question 4 to question 5 that perhaps this is an attention span issue again, or the information requested from the user. Alright, so let's go ahead and mark task number 3 is complete, and we'll go ahead and move on to task number 4. We'll look at the home try-on funnel. So we can see that Warby Parker has a purchase funnel in which they ask people to take a quiz, then they're able to try on glasses at home, which will lead to the purchase of the perfect pair of glasses. Now, Warby Parker was doing an A/B test where 50% of users were given 3 pairs of glasses to try on, and another 50% of users were given 5 pairs to try on. And now we want to look and see if giving the users more options to try on led to the user having a higher rate of purchasing glasses. So the data we need is distributed across 3 tables: the quiz table, the home try-on table, and the purchase table. So the first thing we'll do is we'll evaluate the first 5 rows of each table. So we'll select star all columns from our quiz table, and we'll limit this to 5. Now I'm just going to go ahead and copy this, and we'll change quiz table to home try-on, and then finally we'll change our last table to purchase. So we'll go ahead and run our query, and we want to look at the columns for each table. So for our quiz table, we have a column of user ID, style, fit, shape, and color. For our home try-on, again we have user ID, we have the number of pairs, whether they received 5 pairs or 3 pairs, and we have the address that they were shipped to. And then finally, for our purchase table, we have the user ID again. All 3 tables have the user ID in common. We have the product ID. We have the style again. That should be familiar to our style column in our quiz table. And then we have the model name, and then color, and then finally the price. So let's go ahead and mark step 4 as complete, and we'll move on to step 5. We want to create a new table with the following layout. It should have a user ID column, a is home try-on column. Now this should stand out because we haven't seen a column with that name. The number of pairs column, which is available in the home try-on table, and then finally the is purchase column. And again, we don't currently have a column with that name, so we'll have to figure out how to create that column title and how to figure out if that's a true or false value. So each row will represent a single user. If the user has any entries in the home try-on table, then is home try-on will be true. So that essentially means that if there is a user ID belonging to the home try-on table, then we want the value of true. If their ID is not found in this table, then we'll have a value of false. The number of pairs will come from the home try-on table. And then finally, if the user has any entries in is purchased, so if their user ID is found in the purchase table, then our column is purchase will be true. We're going to use a left join to combine these 3 tables. So we can go ahead and comment out this code, and I'm going to create some more space. So the first thing we'll do is select distinct quiz user ID, and then home try-on dot user ID, and we want to make sure that the value is not null. And we'll give this an alias of is home try-on. So that's our second column. As we can see here, we have user ID from our quiz user ID. Is home try-on is our second column. Our third column is home try-on dot number of pairs. And then finally, our last column is purchase. So we'll name our purchase table and our user ID, and we'll make sure that the value is not null. And we want to name this table is purchase. Alright, so we've selected the columns that we need, and we've provided the aliases that match the table that we're trying to create. And so now it's time to use our joins. So we'll say from our quiz table, and we'll give this an alias of Q, just to clean up our code. So we can make this quiz.userid, Q user ID, and we'll use a left join with a home try-on table, and we'll give this an alias of H, which means we can give this home try-on table an alias of H, this home try-on table an alias of H, and we want the join to be on our Q table user ID being set equal to our home try-on table user ID. And then finally one more left join of the purchase table with an alias of P. So we'll change this purchase table to the alias of P. And again, this is where our purchase table user ID is equal to our quiz table user ID. So we're joining the three tables on user ID, which gives us all the data for each user. If the user did the whole flow, we would see their data from all three tables. If a user took the quiz but didn't do the home try-on, then they wouldn't have an entry in the home try-on table. In terms of data, this will show up as a null value. And we'll restrict this to a limit of 10. So let's go ahead and run our code. And when we do, we can see each record has the user's ID. We can see in the home try-on column that 1 is equal to true, which means that it was a home try-on. The number of pairs for our first record is 3, which means that they were given 3 pairs. And in the in-purchase column, the number 0 means that they did not make a purchase. And so if we look at the first row, we can see that we have a user ID. We have the number 1 for is home try-on, which means that this user reached the second stage of the funnel, and they tried on a pair of glasses at home. In our next column, number of pairs, lets us know that that user is part of the test group that received 3 pairs of glasses. And then finally, we have our is purchase column that lets us know if the user eventually did make a purchase. If the value is 1, it would mean that they did make a purchase, but because it's 0, we know that ultimately this user did not make a purchase. And also to point out, in our third row, where we see number of pairs, there's that 0 with a line through it. This is a null value, because as we can see in the column for is home try-on, a value of 0, this means that they were never part of the test group that received either 3 pairs of glasses or 5 pairs. So there's a null value in its place. Okay, I'll go ahead and resize this window a little bit, give us a little bit more room. And we'll go ahead and mark step 5 as complete, and then on to step 6. Now once we have the data in this format, we can analyze it in several ways. And we can also use the original tables to calculate things like the most common results of the style quiz, the most common types of purchases made, and even more. Now I've written some code that's out of view that I'm going to go ahead and run quickly for you. And this is what we're going to try to work on together. And here's an idea of something else that we can do. I'm going to expand this a little bit, and we can actually track this funnel. How many distinct users took the quiz? How many distinct users reached the home try-on portion of the funnel? And then finally, how many people made a purchase as a result. I'm going to go ahead and undo that code that was out of view, so we have our results back on the right screen as they were. And let's go ahead and create that table. We'll begin with the with keyword. This clause can introduce multiple query names by separating them with a comment, as we're going to be querying our quiz table, our home try-on table, and also our purchase table. Now I'm going to go ahead and use Q as our alias for our quiz table. So let's go ahead and select, and we'll put this within a string, one quiz at stage. This is going to be one column. The title of the column will be stage, and in the first row there'll be a value of one quiz, the first step in our funnel. Then we're going to go ahead and use count, and what we're going to do is we're going to look at distinct user ID. So within our quiz table, we're going to add up all of the distinct user IDs. And this select is from our quiz table, as we've been talking about. So at this point, I want to start to see some results. So I'm going to comment out this previous section, and I'm going to select all from Q. Remember, Q is our alias. And so when we run our code, we see that we have our column stage, we have our value of 1 quiz, and then we have our column with our unique user IDs of 1,000, meaning that 1,000 unique users reach this stage of the funnel. Let's go ahead and move on with querying our next tables. Remember, we only have to use this with clause once, and we can simply use a comma to separate these queries. So I'll use H as, and this is going to be for our home try-on table, and we'll begin with select, and we want our value for our second stage in the funnel. So we'll call this to home try-on as stage. Perfect. And again, we want to get a count of distinct user IDs. So count distinct user ID. And this isn't going to be from the quiz table, but it's going to be from the home try-on table. Okay, so now if we run our code, we're not seeing any new information in our query results. And if you remember from previous lessons that the union all operator is used to combine the results of 2 or more select statements. So let's go ahead and try that out. Before our semicolon, we'll type in union all select all columns from H. H is our alias for home try-on. Now let's go ahead and save our code. And there we have it, occupying the space that we would expect. Now for the third step in the funnel, we'll follow the same process. This might be a good time to actually pause the video and see if you can do this on your own, or we can go ahead and step through this together. Remember, we use a comma to separate our queries, and we're going to be selecting from the purchase table. So I'm going to use P as our alias, and then we'll select, and we'll go ahead and call this 3, as it's our third step in the funnel, and we'll call this purchase. The column title is stage, and we're going to get the count of distinct user IDs. And this is going to be from purchase. All right, and then before we run our code, we'll make sure we do what we did last time. We'll do a union all select, and again, the union all operator is used to combine the result sets of 2 or more select statements. So this will be from P for purchase. So let's save our code, and there it is, just as we would expect. So we were able to query the results of the sales funnel. We were able to get a picture of how many people reached the first stage in the funnel, 1,000 unique users, how many reached the second stage of trying on the glasses, 750 unique users, and then finally the third stage of the funnel, actually purchasing a pair of glasses, 495 unique users. Okay, I'm going to go ahead and comment out this code, and let's do one more query. Alright, in the background, I ran some code to produce a new query. Let's look at this together. We want a column of AB variant, another column of home trial, and another column of purchase. And we'll go ahead and group by AB variant. So this query is taking a look at users in the second stage of the funnel, those who've received either 3 pairs of glasses or 5 pairs. We list the total amount of people who received these pairs, and then we list the amount of purchases, and we list the amount of people who eventually made a purchase. Alright, I went ahead and undid that code so we don't have any query results for now. Our first step will be to use a with statement, and we'll go ahead and give our temporary table the name base table. So the next thing we'll use is our select statement, and we're actually going to select from a few of our different tables. So first from the quiz table, I want all distinct values from the quiz table looking at the user ID. And then from the home try-on table, I'm going to create a value of 1 or 0, and we'll explain why in a moment. And then from the home try-on table, we're going to look at the user ID, and we're going to check is not null as, and we'll name this column is home try-on. So what's going to happen is we're going to look at our home try-on table and the user ID column. If it is not null, it's going to have a value of 1. If it is null, then the value is going to be 0. And we've renamed our column is home try-on. And now our next column is going to be home try on number of pairs, and this is going to be the 3 or 5 and we'll go ahead and name this AB variant. And then finally, from our purchase table, we're going to look at the user ID column, and we're going to do that same check for null. Is not null as, and we'll call the column is purchase. So when we look at the purchase table and the user ID column, if it's not null, it will receive a value of 1. If it is null, it will receive a value of 0. And we're going to take advantage of these values in our query. So this will be from our quiz table, and we'll just give this an alias of Q, just to shorten our code in a couple places. Then we'll go ahead and do a left join. And remember, the left join keyword returns all records from the left table, table 1, in this case quiz, and the matched records from the right table, and the result is null from the right side if there is no match. So we'll go ahead and left join with the home try on table, and we'll go ahead and give this an alias of H so we can clean up this code. And this is going to be on where Q user ID is equal to the H home try on user ID. And then finally, one more left join. And this will be the purchase table. We'll give this an alias of P. So we'll clean this up as well. And this is going to be on P user ID is equal to Q user ID. Okay, now we have our temporary table to query base table that has all of our columns and tables joined together as we would expect. So if we remember, we want our first column to be our AB variant. So select AB variant. Then our second column is going to be home trial. And this is going to be a count of how many people participated in the home trial for 3 pairs and for 5 pairs. So we can do that with sum. And now we're going to have a case. When is home try on equals 1, then 1 is added to the sum. If not, 0 is added to the sum. And then when we are done with all of our checks, we'll use our N keyword, and we'll name this column home trial. And this is what we did earlier. We looked at the home try on table and the user ID column, and we said if it's not null, if there's a user ID, then it receives a value of 1. But if it is null, then that meant it received a value of 0. And that's where this comes into play. Whenever there's an ID in the home try-on, we get a value of 1. And all those ones, for everyone who experienced the home trial, are added together to get our sum. And that sum will be displayed in the home trial column. And if you remember, in our goal, what we're heading towards is we want to have another column of purchase. How many people who received 3 glasses made an actual purchase? And how many people who received 5 glasses made an actual purchase? So we'll go ahead and do that by using sum again. And this is going to be a very similar approach. We're going to have a case of when is purchase equals 1. Then we're going to add 1 to our sum. If not, we'll add 0 to our sum. And then we'll use our N keyword. And we'll go ahead and call this column purchase. And so remember, we're selecting from our temporary table, base table, and we wanted to group by our AB variant column. So let's go ahead and run our code, and we're almost there. We have our AB variant column to see if the user had 3 pairs to try on at home or 5 pairs. We have the results of how many people received either 3 or 5. And then we have our purchase column that lets us know how many people made a purchase that let us know the end result. How many people made an actual purchase. Now in our top row, we have information that's not helpful to us. Because as we've seen, as we've gone through this project, not everyone reached this stage of the funnel. So let's go ahead, and before this closing semicolon, we can simply use having, so that we're doing a check, to make sure that home trial is greater than 0. And so for home trial, we have 0 here, so we're checking to see that. If that number isn't greater than 0, then it won't show up in our query. So let's run our code. Perfect. There we go, just as we would expect. So we can see that for those who are sent 3 pairs, 379 people for their home trial, the purchases were 201. This is a bit over 50%. However, those who were sent 5 pairs of glasses, a total of 371 people, resulted in 294 purchases. This is a conversion rate around 75%. So with this data, where would that lead you next? This is clearly a much more successful way of selling glasses by having users try on 5 pairs instead of 3. So the business decision from this data might be to say that going forward, we always give the user the opportunity to try on 5 pairs of glasses. However, someone else looking at the data might also look at the cost involved. How much extra does it cost the company to send out 5 pairs of glasses versus 3 pairs of glasses? Maybe there's a cost we don't know about that isn't worth this higher conversion rate. But at least we know with this data that that's the question that we should be asking. Let's go ahead and mark step 6 as complete. Alright, great job. This is Rob with Codecademy. Happy coding.